So here's our current structure. We have the shape class with the render method and the group class, which maintains a list of objects. And it has two methods, render and add, which takes an object instance. Now, to treat these types the same way, we need to extract what is common between these two types and put it inside a base class or an interface. What is common between these two types? It's the act of rendering. Both these types have a render method, right? So we need to introduce an interface called component and declare the render method here. These types are going to implement the render method differently. Now, with this structure in our group class, instead of maintaining a list of object instances, we can store a list of components. Because a component can be a shape or a group, right? So inside a group, we can have shapes and other groups. This is how we can represent a hierarchy. Similarly, we should change the signature of the add method. And instead of getting an object instance, we should get a component instance. So we pass a component here, the add method takes it and adds it to this list. Pretty straightforward. Now with this structure, in our render method, we no longer have to check the type of each object and explicitly cast it to a shape or a group. Because when we iterate over this list of components, we're dealing with component objects. Every component has a render method, so we can simply call it without having to explicitly cast it to a shape or a group instance. And this is what we call the composite design pattern. We use this pattern whenever we want to represent a hierarchy and we want to treat the objects in this hierarchy the same way. Whether they're containers or parts, we want to treat them the same way. As another example, think of your file system. On your file system, you have files and folders. If you delete a folder, you want all the files and folders in that folder to be deleted recursively. This is another place where we can use the composite design pattern. Here's the structure of this pattern in the Gang of 4 book. So on the top, we have this component interface, which declares an operation that is common between parts and containers. So this leaf class represents an individual part. It's like our shape class, and the composite class is like our group class. It's a container. This is where the name comes from, because this composite class can be composed of 0 or more components. Each component can be a leaf or a composite object. This is the structure of the composite design pattern. So next, we're going to implement this in code.